Okay, hello, this is Robert Bontrager again. Last time I showed you how to send a laser tag signal. Now I'm going to show you how to receive a laser tag signal. And once you understand how to do this, then it's just up to you as far as what you can imagine that you want to build for a laser tag device. So, how to receive a laser tag signal. Again, we're using the LTTO protocol. And again, that protocol is found on the Google patent. Look up device and method for an electronic tag game. This is what is used in the 2004 LTTO Laser Tag Team Ops with the Deluxe, the drone, the Master Blaster, the LTX, and the LTAR. Other information is also can be found on the Laser Swarm wiki page. But I'm going to show you how to receive a tag. So let's get started. We're starting from a blank sketch here. We're going to first define a variable. Constant byte IR equals 4. The next variable is int pulse 9 semicolon. All right, so we got int byte, and int tells the Arduino how much memory space do you want me to allocate, reserve for this variable. And so for pulse, we're allocating a larger space because we want value. We're going to have values larger than what a byte can hold. A byte can hold up to a value of 255. We're going to have values larger than that, so we have to go with an int. Okay. The variable is going to be used 9 times, and we'll see that later on. This is a variable array called pulse. Perfect. All right, so next we're going to go to setup. We're going to go pin mode. IR sensor pin input. So we're saying our sensor pin is going to be an input, meaning we're going to use this on the Arduino to receive information. Okay, last time we used the pin to send a signal out, so we called it an output. Here we're using it as an input. And then what we're going to do is we're going to do another thing. This is new. We're going to call serial begin. We're going to print the information that we receive from a tag to a serial monitor. So that's how we can see if we're actually getting something. Okay. So in order to do that, we're going to start the serial port. And this number here is the baud rate of how fast we're sending the data information to the serial monitor. And once you have that, and LN means line, print a line. That means after you're done printing this, hit the return key or go to the next line. And by the way, if you want to learn more about how different functions or how to code in Arduino, if you just go to arduino.cc and then go to resources, reference, here you have all sorts of things that you can type in your code. So if you're not sure why I'm explaining something or how something works, you can come here and get further information. Okay, so we got the serial monitor ready to go. So next we're going to go to our loop function where it keeps cycling over and over again. So in our loop, we're going to say get tag. Okay, and that's it. We're just going to get tag. So now we're going to create the function void get tag. We're going to use our variable pulse, and we want to make sure that it's set to 0 because we're going to use this pulse variable a lot. So we want to make sure that it's always set to 0. So we're going to use a for loop for byte x equals 0 x less than 9, x plus plus. And then we want it to pulse x equals 0. So this 4 means we're going to do this essentially 9 times. So we're going to declare a variable x equals 0 while x is less than 9. Do this. After you've done this, add 1 to x. X plus plus is shorthand for x equals x plus 1. Okay? So once everything's zeroed out, and the secret sauce for receiving a tag is this: pulse. Pulse in. And what pulse in does is it looks for a pulse, a frequency pulse on a pin. If it sees a pulse, then we're going to tell it to do something. Pulse in, IR, where do we see this pulse? We're going to see it on the sensor pin. And once the pulse goes low, and I'll tell you what this number does in a second here. Okay, so if this condition is true, we're going to do what's in this bracket. What is the condition? Pulse in. If we see a pulse on this pin, and this pin stays low for more than 2,500 milliseconds, then we know that we have received a signal. What signal is it? Well, going back to our sheet here, it's going to be this. So once we see a signal, remember, when there is no signal, it's going to be high. Once a signal comes in, it's going to go low. So that's why we say once it goes low, do something. So what signal is it going to be? It's going to be this. This is going to be the first thing that we'll see, and it's going to be 3. Okay, if it's at least 2,500 milliseconds long, then it's probably that first pulse. Great. So if we see that first pulse, now we're going to do something else. Now we're going to look for our next pulse, because that's what happens. There's going to be another pulse. If and we kind of do the same thing. And now what we want to do is we want to say it's less than 3,200. Because remember, if it is, this is the second thing that we're looking for right here. This is the second thing we're looking for right here. If it's 3, that means it's going to be a tag. Now, if it's longer than 3, it's going to be a beacon. For right now, we're going to just ignore all beacon signals. We're going to look at tag signatures, okay? So if we have a pulse here, we go to this next one, look for the second pulse. Now what we want to do is we want to read in all the data, because now after the second pulse, we're going to have the actual data. So we say pulse 0 equals pulse in IR sensor pin low 5,000. So the first pulse 0 is going to read the pulse in from the sensor pin as long as it's low. And then this number here, 5,000, is a timeout signatures, meaning if after 5,000 milliseconds, if we, I'm going to take a look, can't write pulse in. So I'm going to come here, can't remember. So I'm going to look here in my sheet here. This is on the Arduino CC site. So pulse in, here it is, pulse in. So pulse in timeout is in microseconds. Okay, so this is 5,000 microseconds, which is a microsecond is 1/1,000,000th of a second. So 5,000 is 5 milliseconds, or 5/1000th of a second. So we wait effectively 5 milliseconds for the next one, and that helps us to keep moving the program along. So I found that this works really well to put this in here. And conversely, that's what this means. This means wait basically a quarter of a second. Okay, because we don't want to hang out there too long. We want to be able to do other things in our sketch. So we just kind of wait a quarter of a second. Anyways, so we put pulse 0 in here. Then we want to put the next pulse in. And we effectively keep doing the same thing. So I'm just going to copy this. So we now got our pulses in. Now I could have effectively done a for loop, but I like doing it this way because I see exactly what's happening. So pulse 0, we have this coming in, pulse 1, okay? Great, so now we have a pulse in, okay? Now, you might be asked, so this is pulse 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9 here. Why do I have 9 when a tag only has 7 points, okay? Well, the reason being is that there's other things here that send data as well. For example, this here, 1, 2, 3, 4, 5, 6, 7, 8, 9. This can have 9 bits of data, and it still has this 3 milliseconds signature here. So it could be a checksum that it might get. And so I don't want to interpret this as a tag if indeed that's what this is. Okay, but I still want to allow to receive this data that's here. So what we're going to do now is we're going to take a look at these last 2 data input, because if we have a tag, all this will have data except these 2. If nothing comes in after we timed out after 5 milliseconds, it will just be a 0, and same with this one. Okay, so now what we're going to do is we're going to see if indeed we have any data here in these last 2 pulses. So we say if pulse 7 equals 0, and if pulse 8 equals 0. Okay, so if both of these conditions are true, then we want to do stuff that's in these brackets here. And the reason why we do double equal signs, because if we just did one equal sign, what you're telling the Arduino is that I want to make pulse 7 equal 0. I want to force it to be 0. But if we want to see if it's 0, we have to do double equal signs, and that has caused me so much problems. I've put single, and it's like, why is this not working? Okay, and the same with this. We have to make sure that we have to do a double because we're just seeing. If we just do a single and, it's going to do something with our data. We want to double. So if these last 2 pulses are 0, then we know, we have a tag. Great. Now what we're going to do is we want to create a new function, print tag. So now if we have a tag, we're going to print the tag. We're going to do a new function here. Okay, perfect. So now let's go ahead and do that function. Void print tag. Okay, so to print the tag, we're going to do this. We're going to go serial print line. And you can do whatever you want. This is what I came up with. Tag. Tag received. We're happy. We received a tag. Okay, so we're going to print one line. It's going to print this tag received. And the ln means that we're going to do a return. Then we're going to do a for loop. Byte x equals 0. X is less than 7. X plus plus. And then what we want to do is we're going to say serial print line pulse x. Print line meaning just print a blank line. And then when we're done, we come back up here. go to get tag. And so we do this all over again. And so we wait, we receive a signal. And this is why we reset this to 0, because once we receive a tag, we want to make sure it's back at 0. So this is our function. This is all you have to do to receive laser tag information. So let's hook this up and see it work. All right, so now let's wire this up to receive. So I've got here, this is a standard infrared detector. This is most common types. We've got 3 pins on this, and this pin here on the end is going to be, make sure, yeah, that's going to be negative. The middle pin is going to be our positive voltage, and then this last pin here on the left is going to be our signal. So when this sends a signal, this is where we get the information from. Or in other words, when it doesn't see a 38 kilohertz tone, it will be high. When it does, it will be low. So that's how that works. Okay. So I happen to have here on my breadboard 2 wires already going to the negative and positive channel. Okay. So I'm going to go ahead and put this in like so. There we go. So now we have positive and negative. So I just going to wire up these power rails here to positive and negative voltage. And then this last one goes to our signal. So we'll put this here. And then our signal, we said, was pin 4. So let's find pin 4 on here. And we'll go here. Pin 4. Right there. Okay. Great. Pin 4, and now we're just going to wire up our voltage. So on the Uno, there is a 5-volt line here, and so we want to hook it up to the 5 volts. There's a 3.3 volt one too, so we want to make sure we're not using that one. We want to use the 5 volt, and then we just plug this into one of the ends here, and then we're going to go to ground. And this goes to ground. Perfect. And that's it. That's all we got to do. So I have my sketch here. I got to plug it in first. Plug it into my Arduino. And so now let's verify we don't have any errors in this sketch. Looks good. So now we're going to go ahead and send this to the Arduino. We verified that we're on the right COM port and we are using the Arduino, and there we go, we uploaded. So now our sensor is waiting to receive a tag. Great. So what we'll do is we're going to use an LTX, because an LTX does not emit a beacon signal. Now, some of you may not know what a beacon is. This kind does have emit a beacon. You can see some IR LEDs in here. This does not have that. This just has those are just regular red LEDs, okay, when it lights up. And this is used to send information, like hit information and everything, back to other laser tag guns. That's why you have 2 barrels here. One sends a laser tag signal, the other one receives. I'm not sure which one it is, but anyways, this does not emit an infrared beacon. So we're going to use this as our first test. So let's go ahead and go to a solo, and we're going to go ahead and power this up. And I'm going to switch to the Arduino again. And I'm going to open up something called serial monitor. Remember, this is what we're going to use to read the data here. Okay, so now we're going to go ahead and receive a laser tag signal. And there we go. And you can see we're having 1, 2, 3, 4, 5, 6, 7 bits of data. And each one is about 1,000 or less. Oh, this one was almost 900. maybe because my batteries are weak. But anyways, we're in that range, and so everything is effectively a value of 0. Let's go ahead. I'm going to turn this off. I'm going to go to a Team 2 grab and go game, and we'll see if we see something different. Okay, here we go. Yes, right here. So this is consistent with being a player 2 on a grab and go game, because these first 2 is a value of 0 for a special game, and then this one represents Team 2. So we're receiving tags and we're getting the information as we expect it. Cool. Let's try a gun that has emitting a beacon and see how well it rejects beacon noise. Because remember, a beacon, that sync pulse is greater than 3 milliseconds. So we're going to use a deluxe here, and we're going to try this. So I'm going to switch to our screen, and so now the deluxe is constantly sending out a beacon signal, but our Arduino is rejecting it because it sees that second pulse is longer than 3 milliseconds. So it says, I'm not going to do anything. But let's shoot this. There we go. And here we're getting more consistent results around 1,000. And it's receiving hits real fast. So let's now, I'm going to reload. These have the ability of doing a mega tag, so I'm going to load up with the mega tag here. So this is a 4-point shot. There we go. Gun overheated, of course, but there we go. We're receiving the tag, and that's exactly how you do that with the Arduino. So now you know how to send a tag, you know how to receive a tag. Now we're going to look at how we can possibly combine the two to create something useful out in the laser tag field. Maybe a Sentry device where you can shoot it and it will automatically repeat your tags. The Sentry repeating gun out in the field. So let's see how we can write the code for that. Thanks for watching.